Welcome to the video on derivatives by definition. In this video we're going to find derivatives of some functions using the definition. So first of all, we need to remember what is the definition of the derivative. Given a function f, its derivative is called f prime of x and is defined as the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And when you want to find the derivative of a specific function f, you simply have to replace here f by the expression of the function. So we're going to solve some examples. Here we're going to consider the function f of x equals x squared. So to find the derivative, we need to solve this limit, but replacing f by x squared. So here we replace f of x plus delta x will be x plus delta x squared, and f of x is x squared. And now it is only after you written this equation, it is only an exercise in solving limits. So you can use all your skills for solving limits. In this case, the only thing we can do is to expand this factor, this term here. We can expand this. Well, here we have f of x plus delta x and f of x. So we're going to expand this term like this. This will be x squared plus 2 times x times delta x plus delta x squared. And then we have x minus x squared. Here these two x squared cancel, and we have this limit. The limit of this expression. And you may already recognize how to solve this limit. We can solve this limit by factoring. We can factor the delta x here, and we get delta x times 2x plus delta x. And here we can cancel the delta x, and we get the limit of this expression. But here delta x is approaching 0, and well, here x is a constant, and we are used to having x being the variable, but here we're taking the limit as delta x approaches 0. So delta x is the variable and x is a constant. So the limit of a constant is just the same constant. So this equals 2x. So this is the answer. The derivative of x squared is 2x. Let's solve another example. Let's consider the function f of x equals the square root of x. So we write the definition of the derivative once again. And here we replace f of x plus delta x will be the square root of x plus delta x, and f of x will be the square root of x. So in this case, this limit can be solved using the technique of multiplying by the conjugate. So here we multiply and divide by the conjugate of the expression in the numerator. Here we multiply. Well, and here in the numerator, when we multiply these two factors, we get the difference of the squares of the two factors. And here, well, when you have a square root, the square root disappears. So we have x plus delta x minus x, and here the x disappears. So we have this expression. And now we can cancel the delta x. So you can see that the idea is always to make the delta x in the denominator disappear, because it is approaching 0, and having a 0 in the denominator is not a good idea. So we here cancel delta x, and now we have this limit but here that x is approaching 0 and x is a constant, so this equals 1 over the square root of x plus the square root of x. That equals 1 over 2 square root of x. That's the answer. So the derivative of the square root of x is 1 over 2 square root of x. So those were two basic examples. In the following videos we may find derivatives of more complicated functions. So that's all for now. Thank you for watching and see you next time.